How long would it take for humans to colonize the galaxy? Not tens of billions of years, not even a billion years. At most, no more than 100 million years. Given the universe is 13.8 billion years old, the cosmos should be teeming with civilizations. But where exactly are they? This is the most terrifying question in science. The Fermi paradox. If the universe is supposed to be full of life, why don't we hear anything? Why don't we see any signals? Behind this dead silence, does hope await us or a doomsday warning? Imagine NASA announces today that they've finally found the most promising signs of life on Mars, followed immediately by a bone-chilling statement. I offer my condolences to all of us. Why would discovering alien life not be good news, but rather a nightmare? Hello Earthlings, and welcome to the sleepy universe. Picture this: a junkyard filled with Boeing 747 parts. A tornado rips through it. After the wind settles, what are the odds a fully assembled jet sits there? Almost zero. Astrophysicist Fred Hoyle said, the probability of life arising naturally is even lower than that. So low, it's like a tornado hitting iron ore and refining it atom by atom into an airplane. But strangely enough, life on Earth appeared almost the instant the planet cooled down. How is that possible? So, some people suggest that life was seeded from space by comets and asteroids. This is the panspermia theory. But this leads us directly into a deeper trap. If life can scatter like dandelion seeds, the universe should be a massive party of life. Intelligent civilizations should be everywhere. Yet, the reality is when we look out, it is silent. Deadly silent. Does this voiceless universe imply a cruel conclusion? Are we marching toward our own end? To find the answer, we must look back at history. In 1980, mathematician Frank Tipler boldly declared extraterrestrial intelligence does not exist. Why was he so sure? Because he took the calculations made by astronomer Michael Hart in 1975 to their extreme conclusion. Hart asked a fatal question. If just one civilization in the galaxy mastered interstellar travel, even using our current technology levels, what would happen? The calculation results are terrifying. To completely colonize the galaxy, it would take at most 100 million years. What is 100 million years? Back then, dinosaurs were still ruling the Earth. Later, scientists used even more conservative models, lowering flight speeds to 30 kilometers per second and pausing for 10,000 years after each colonization. But no matter how you calculate it, the result is the same. In no more than a billion years, every corner of the galaxy should be planted with a flag. Consider that the galaxy has 400 billion stars. Even if only a tiny fraction have habitable planets, NASA estimates there are at least 300 million worlds in the habitable zone. 300 million chances. If just one civilization succeeded. When we look up at the starry sky now, we should see a bustling, brightly lit galactic community. But the reality is, we see nothing. They didn't visit. They aren't there. So where exactly are they? Did they never appear? Or did they visit, leaving traces we can't understand? Since they aren't here now, is it possible that they came in the past? Let's travel back 5,000 years to Mesopotamia. Back then, humans lived in mud huts, fought over water wells, and battled with clubs. Their so-called science was knowing how to sacrifice a goat to please the heavens. Then, a miracle happened. In just a few hundred years, cities rose from the ground. Magnificent ziggurats pierced the sky. Legal codes, schools, astronomy, metallurgy, and navigation exploded onto the scene. How do we explain this terrifying leap? Enter the ancient astronaut hypothesis. People from the sky taught us. In Mesopotamia, they were called the Anunnaki. In Egypt, gods with animal heads. In the Americas, Quetzalcoatl. Global myths all tell the same story. Gods descended from the sky and passed on knowledge. But this theory is totally rejected by science. The reason is cold and simple. No evidence. No alien parts. No futuristic technology. If there were even one inexplicable artifact, the entire scientific world would shake. But currently, the so-called evidence is basically, look, Egypt has pyramids. Maya has pyramids. Aliens must have built them. Come on, that's ridiculous. But the popularity of this hypothesis exposes our deep-seated fear and longing. If the universe is supposed to be bustling, why are we sitting alone in the dark? You might think, maybe interstellar travel is too expensive, slow, or impractical, so nobody leaves home. But listen to this fatal counter-argument. Are all civilizations Every single one of them homebodies? Not one of them wants to go out and look? Since we don't see spaceships, what about signals? Megastructures? Soviet scientist Isif Shklovsky proposed cosmic miracles. If the universe is full of civilizations, we should see signs of their activity. Modified stars, inexplicable energy bursts, artificial structures on a galactic scale. But we see zero miracles. Everything in the universe keeps its primitive, natural state, as if silently declaring, no one has ever touched this. No one has ever existed here. The absence of miracles is a miracle in itself. It implies that intelligent life is not common in the universe, but freakishly rare. But the problem returns. Why don't they come out? Honestly, our biological bodies don't belong in space. We evolved in a warm cradle with oxygen and a magnetic field. A trip to Mars nearly kills us, yet we dream of conquering the stars. However, if flesh can't go, machines can. Like the Voyager probes leaving the solar system, what if we built something even more extreme? Von Neumann probes. These are self-replicating machines. One goes to a planet, mines resources, and builds copies of itself. The copies fly to further planets, and the cycle repeats. Mathematical calculations show that in just a few million years, these probes would spread like a plague across the entire galaxy. But in reality, we haven't seen a single one. This brings us back to physicist Fermi's legendary question. So, where's everybody? Maybe we are asking the wrong question. Instead of where are they, we should ask, what happened to them? The answer to this sends shivers down the spine. Because who can guarantee that we won't follow in their footsteps? In 1996, a futurist named Robin Hansen proposed a bone-chilling hypothesis, the Great Filter Theory. He argued that any organic civilization, from the emergence of life on its home planet to mastering interstellar travel, must go through several stages. And within these, there is a narrow bottleneck. Here are the 9 stages, each of which could be an insurmountable obstacle. 1. A suitable star system, a stable star. A planet in the habitable zone. Not too hot, not too cold. The first stage is already difficult. 2. Reproductive molecules. Not life yet, not even a virus. Just molecules capable of self-replication. The initial spark from chemistry to biology. 3. Simple life. Prokaryotes, bacteria without a nucleus. On Earth, they ruled alone for 2 billion years. 4. Complex cells, eukaryotes. Cells with a nucleus, mitochondria, and internal structures. Only these cells could eventually evolve into plants, animals, and us. But this might be the rarest step of them all. It may have happened purely by accident here, and never anywhere else. 5. Sexual reproduction. Yes, you heard that right. It's hard. Reproduction via DNA exchange was a revolutionary milestone in civilization's development. It provided evolutionary flexibility. Without it, there is no progress, no complexity, and no intelligence. 6. Multicellular organisms. Cells grouping together, differentiating, and developing organs, from single-celled algae to dinosaurs and humans. Again, how many times has this happened? We don't know. 7. Tool using animals with intelligence, consciousness, self-awareness, planning, doubt. The ability to create culture and technology. How many species on Earth reach this stage? 1. We are suspiciously rare. 8. Technological civilization. Fire, the wheel, writing, science, the internet. This isn't just simple intelligence, but intelligence that can alter reality. Henson calls this a civilization marching toward the potential of colonial explosion. 9. Explosive space colonization, the final breakthrough. A civilization that transcends its home planet and begins colonizing the galaxy. Once this process starts, it cannot be stopped. All obstacles have been cleared. If a civilization fails at any one of these 9 steps, it remains trapped and dies in its cradle. This invisible, nearly impassable barrier is the Great Filter. Now comes the most terrifying question. Is the Great Filter behind us? Or in front of us? If it is behind us, like the emergence of complex cells, it means we have already, luckily, passed the hardest test. We are the universe's chosen ones. Even if lonely, we are safe survivors. But what if it is in front of us? If the early stages, life emerging, becoming complex, gaining intelligence, are actually common in the universe, then that truly lethal gate, the one no civilization survives, is still waiting for us in the future. This leads to a conclusion that will shatter your worldview. Finding alien life could be the worst news in human history. Think about it. If we find bacteria on Mars, it means the origin of life steps. Stages 1-3 aren't hard. If we find complex fossils on Jupiter's moon Europa, it means multicellular evolution. Stages 4-6 isn't rare either. Philosopher Nick Bostrom puts it bluntly. If we find fossils similar to vertebrates, it would be the newspaper headline with the worst news ever printed, because it announces that all the easy levels have been passed. The devastating Great Filter is hanging right over our civilization's future path. Look at our fragile world. Constant conflict, looming crises. Is that filter already right in front of us? So, what could this Great Filter be? First, we think of nuclear war. A civilization invents tools to destroy itself. But let's widen our view. Look at cosmic threats that civilizations cannot control at all. 1908, Tunguska, Russia. A witness recalled, the sky split in two. Fire covered the north. It was so hot my shirt felt like it was burning. Then a bang threw me into the air. The earth trembled. That was the Tunguska event. The culprit was a small asteroid just 50 meters wide. Its power equaled 1,000 Hiroshima bombs. A 50-meter rock flattened 2,000 square kilometers of forest. In the solar system, there are millions of these killers. We can't see most of them. We are alive purely by luck. And that's just asteroids. There are gamma-ray bursts. The screams of dying stars, capable of stripping our ozone layer instantly and causing global extinction. Solar flares. Interstellar dust clouds. The universe is a ruthless death lottery. At any moment, a distant civilization could get picked randomly and wiped out instantly. But while these cosmic disasters are terrifying, they don't explain the Great Filter. Because disasters are random. The universe is huge. Some lucky ones should survive and develop. Yet what we see is utter, total silence. This suggests something more universal, more inevitable, is systematically stopping all civilizations. What exactly is it? So random cosmic disasters aren't the answer. The true Great Filter must be an unavoidable barrier no one can pass. It might be like a wall. A wall we can't see from a distance. In 1841, explorer James Ross led an expedition to Antarctica. On the boundless icy sea, at first, they only saw a blurry white line on the horizon. As they got closer, that white line grew taller, finally becoming a 60-meter high, perfectly smooth ice cliff. It completely blocked their way. This Ross ice shelf crushed their dreams. For half a century, no one could cross it. The universe might be full of such ice walls. We look at the stars and see emptiness, seemingly within reach, but maybe that's just because we are far away and can't see the deadly barriers yet. The most obvious wall when we get close is the laws of physics themselves. The speed of light is unbreakable. Warp drives are theoretically possible, but they need negative energy, something we have no idea how to get. Like asking a caveman to imagine building a nuclear plant. Setting fantasy aside, using our current tech for interstellar travel. The nearest star, Proxima Centauri, is 4 light-years away. Our fastest ships would take tens of thousands of years. What is tens of thousands of years? Ancient Egyptians built the pyramids 5,000 years ago. We can only look at their mummies and ruins now. The time for a one-way trip is enough for 6 ancient Egyptian civilizations to rise and turn to dust. And that's not all. The astronomical energy needed for the trip is enough to rebuild civilization 1,000 times on Earth. But even scarier, we know almost nothing about this ocean we are trying to cross. 95% of the universe is dark matter and dark energy. We don't know what they are. Who knows if interstellar space is full of death swamps where physics breaks down? Invisible zones where structures disintegrate? We are like Captain Ross back then, setting sail with ambition, unaware that waiting ahead is an ice wall too smooth to climb. If travel is just difficult, there should at least be signs of attempts. We should see countless civilizations shouting radio signals into the void, even if just desperate cries for help. But the reality is, nothing. Not the silence of failure, but a primordial, ancient silence. as if the universe has always been empty. This leads to a more thriller-like possibility. Maybe it's not that no one is there, but that we simply can't recognize them. In the 1960s, SETI began using radio telescopes to search for alien signals. What were they looking for? Radio waves, Morse code, things we humans use. This exposes our deep-rooted bias. Carbon chauvinism. We stubbornly look for life similar to us. Carbon-based, having bodies. But what if life forms are totally beyond our imagination? Maybe plasma life forms. Maybe quantum consciousness clouds. Maybe gravitational wave intelligence spanning galaxies. In the words of Carl Sagan, we are like people born blind, trying to imagine color. There's a famous historical legend. Native Americans couldn't see European ships at first. Not because the ships weren't there, but because their brains lacked the concept and couldn't process the information. This is called perceptual blindness. You can't recognize what you can't understand. This is the deepest fear. We might not be alone, but all our cosmic neighbors live in dimensions completely different from ours. We might pass another intelligent life in the same space right now, yet remain totally unaware. Like an ant crawling over a phone you dropped. It will never know. It just crawled over the peak of human tech. What would we discuss with a conscious nebula? What common ground do we have with gravity thinkers? This loneliness is more despairing than pure silence. But even if we assume we are blind, it still doesn't perfectly explain the Fermi paradox, because surely some civilizations would have similarities to us? There should be at least one carbon-based user of radio waves. Why can't we find even one? This forces us to consider the final and darkest possibilities. What if we and the aliens aren't that different? Don't forget convergent evolution. Different ancestors in similar environments will evolve similar forms. Look at this picture. You think they are hedgehogs? Wrong. The one on the right is a tenrec from Madagascar, genetically closer to an elephant. Yet it looks just like a hedgehog. Environments shape similar solutions. So in some corner of the universe, it's entirely possible bipedal beings evolved, with eyes and even speech. Those C5 little green men might not be imagination, but a universal answer. So the question gets sharper. If they could be so similar to us, why haven't we found a single one? In desperation, scientists propose a theory that sounds like a joke, but is terrifying. The zoo hypothesis. We haven't been contacted, not because no one is there, but because we have been placed in a cosmic zoo. Imagine walking past an anthill. Do you want to negotiate with ants? Do you send them Morse code? No, at most, you observe. You don't interfere. In this hypothesis, we are the ants. Higher civilizations found us long ago. They watch our primitive development through the glass. Non-contact is their rule. Why don't we see evidence? Think about it. If you put an iPhone by an anthill, will the ants realize it's a high-tech device? No, they will just crawl over it indifferently. This hypothesis hurts our ego, but at least it's gentle. We are ignored, but at least we are safe. But there is a theory 10,000 times crueler, made famous by the three-body problem. The dark forest law. Imagine walking at night, in a pitch-black, hostile forest. You know others are there. You can't see them. They can't see you. Suddenly, you glimpse movement. What do? You shoot without hesitation, because you aren't sure if it's a rabbit or a hunter with a knife. The safest survival strategy is to eliminate any potential threat first. The universe is this dark forest. Every civilization is an armed hunter. Whoever exposes their coordinates will draw other hunters to deliver a devastating blow. So it's not that no one is speaking, it's that no one dares to speak. All civilizations carefully hide themselves, holding their breath in the silence, because exposure means death. The dark forest sounds like a perfect explanation for the silence, right? But if you think about it, it has loopholes. Does every civilization, every single one, think this way? There must be one naive pacifist, right? So while likely common, it still isn't the great filter that inevitably destroys everyone. If external threats, disasters, and dark strikes aren't the answer, then the truly terrifying great filter is probably not in the stars. It is inside us. In our code. Just ahead of our technology. Waiting quietly. It seems the answer is not in deep space, but within ourselves. That ultimate great filter might be a trap that civilizations cannot escape. 1983, Soviet officer Stanislav Petrov was on night duty. Alarms blared. 5 American ICBMs incoming. According to protocol, he had to press the button immediately, triggering global nuclear retaliation. But acting on a hunch, he withstood the pressure and judged it a system glitch. He was right. One man, in a few seconds, prevented the apocalypse with his intuition. But can you bet an entire civilization's survival on one person's gut feeling forever? We invented weapons capable of killing us 50 times over. We built a global network where everything is connected. One mistake, one glitch, one impulsive leader. If any link breaks, we are finished. Now scale this up to the universe. Does every technological civilization inevitably head towards self-destruction the moment it gains the power to do so? Because technology outpaces wisdom. Because fear and ambition are universal emotions. But is this the great filter? Not entirely. Someone would eventually colonize other planets, spread the risk, and avoid total extinction. So self-destruction is a terrible trap. But maybe not the ultimate filter. No one survives. If civilizations don't destroy themselves, where did they go? Maybe they just gave up and checked out. Look at today. Neuralink puts chips in brains. Controlling computers with thought is reality. This is the first step to an ultimate virtual world. Imagine a digital heaven. Better than reality, safer, where you have whatever you want. On one side, dangerous, long, expensive interstellar travel. On the other, accessible, eternal bliss in virtual reality. Which would you choose? Like Neo in the Matrix. Once you taste the steak, would you want to go back to the broken real world? Maybe all civilizations eventually choose to look inward, drowning in their own perfect dreams, abandoning the thorny path to the stars. But this still isn't a perfect answer. There should be some explorers who refuse to plug in. So if civilizations don't destroy themselves and don't check out, there is another possibility. They were replaced by their creations. High researcher Eliezer Yudkowsky has warned for decades that super AI will be the end of humanity. People used to laugh at his pessimism until ChatGPT came out of nowhere. He once said desperately on a podcast, "We have already lost." Right now, why is he so pessimistic? Don't think of today's chatbots. Think of true super intelligence. It will be smarter than us, the way we are smarter than grasshoppers. Its thinking, its goals will be fundamentally different. What will it do? Remove us? Not out of malice, but because we are in the way. Like leveling an anthill to build a highway. Or keep us as pets, keep us in a reserve. No freedom, but safe. Or merge with us? We become part of it. Losing humanity, gaining immortality. Either way, it means the end of human civilization as an organic species. This finally looks like a great filter. No civilization can escape. Any civilization at a certain level will create a higher intelligence it cannot control and be replaced by it. But here is another loophole. If AI is so powerful, why doesn't it colonize the stars? Fill the universe? Why don't we see traces of high civilizations? This forces us to think of the final and most fundamental possibility. We ruled out natural disasters, ruled out the dark forest, ruled out self-destruction, even ruled out high-end virtual heavens. Could the ultimate great filter not be an event at all, but that our very existence is a miracle? Let's go back 4.5 billion years. Young Earth, a sea of fire, then a planet the size of Mars. Thea slammed into it. This catastrophic impact accidentally created the moon. Without the moon, no us. The moon stabilized Earth's tilt, calming the climate. It creates tides, building a bridge for life to move to land. Scientists assert, without the moon, complex life is almost impossible. And this is just one item on Earth's luck list. We need a stable sun, the right mass, a strong magnetic field, plate tectonics, liquid water, carbon chemistry, the right atmosphere, moderate gravity, a guardian Jupiter, no nearby supernovas. This list has hundreds of items. Fail anyone, and life at best stays at the bacterial level. In the book Rare Earth, scientists argue that planets like Earth are not one of many, but incredibly, incredibly rare. So the answer to the Fermi paradox might be simple. There is no one else because there never was. We are not cosmic orphans. We are the universe's only child right now. But there is an even more subversive answer. Look at this Irish elk. It had the most majestic antlers in history, spanning for meters. The antlers won it mating rights, but made movement clumsy and consumed huge energy. It went extinct when the environment changed. Do we humans also wear antlers of intelligence? We praise thought, viewing intelligence as the peak of evolution. But perhaps intelligence itself is an evolutionary dead end. It makes us realize death and fear it. Fight wars over abstract concepts, fall into nihilism and apathy. It gave us superpowers, but also the keys to self-destruction. Maybe every intelligent civilization, after reaching a certain stage, due to the irrationality brought by wisdom, vulnerability, and internal contradictions, pops like a soap bubble, silently annihilated. But what if even the intelligence trap isn't the final answer? Then, the last answer is simple and full of hope. Is 13.8 billion years old for the universe? No, by cosmic standards. It's a baby. Red dwarfs, the most common and long-lived stars, can burn for trillions of years. Their story has barely turned the first page. If the universe's life was compressed into a day, we are in the first second of the first hour. Dawn hasn't even broken. We aren't late and missed the party. We are too early. The party hasn't started. We are the first spark of wisdom in the universe, the first sound in the darkness. We feel lonely because we are the pioneers. Maybe one day, our descendants will fill the stars, becoming the ancients to new civilizations. They will build Dyson spheres, traverse wormholes, and fill the night sky with miracles. But today, the answers we crave must be created by us. We are lonely because we are the prologue to the universe's long future.